All right, reactions that are in acidic solution and a redox reactions. Right? Well, you do them exactly the same way you did the other ones, but you're allowed to do something else at the end. Okay? If it's in an acidic solution, you have to use your head. What does an acid do? He donates hydrogen ions. He's going to make hydronium ions. All right, so you can add to either side. If you've noticed, you've got waters pretty much in every one of these. And you also notice several of these have H's in them. All right, well, you can now add H pluses, that's hydrogen ions or protons, and waters, and/or waters, to either side to balance the reaction. They're not written in the initial reaction, but you can add them as much as you want because it's in an acidic solution. So when I give you the examples, it will not have an H plus or a water anywhere in that problem. You may or may not need to add an H plus or a water or both or neither. You don't know. All right, but you'll be able to tell at the end when you have to balance them by inspection. And that's where that comes in. Only in the last step, the balancing by inspection, which I haven't made clear yet. The way I'm doing these, how many points is that last step worth? One. All right, so on a test, you're probably going to get 10 of these. 10 problems like this, as you copy it down. And you're going to lose 1 point only out of those 10 for balancing that last step by inspection. Now, think about it. Some of them, that last step is really easy. Some of them, you don't even have that last step. There is no balancing by inspection. So you're going to get, without one correct answer, you could not do the last step and still get a 91 or a 92 on this test and not have a correct answer on it. Okay? Where are most of your points going to come? Surprisingly, from mistakes made early on, including in the oxidation numbers. Let's take a look at the mistakes we could make in this oxidation numbers. Let's see. Br is not -1. He's 0. Okay, because he's by himself. O2 looks like a polyatomic ion, but he's not. He doesn't have a charge up above him, and he doesn't have, I always put parentheses around him. So he's a -2 +4. Got it? Okay. Br with a -1, another little mistake here. That is a monatomic ion. He has a -1, so he does have that charge. All right, this is a polyatomic ion, -2 +6. By the way, somebody last period, and this is not a surprise because these are people who did not have me last year, so did not see this ever before. People like Dayton and Jesse in this class who never saw this before. All right, they were just doing, because I wasn't only taught it for one day, they were just doing the charge of the polyatomic ion and trying to do it that way. You can't do that. You got to have the guys inside of there because, as you've probably already noticed, some of those guys are changing inside of there from one side to the other. So you have to do your individual oxidation numbers, not just the charge of the entire polyatomic ion. All right, so there's your first step. By the way, this is about as easy a problem as you'll ever get on a test. I'm showing you the easy one. Why? So I can illustrate this part, you know, the adding of H's and waters, not to show you how to balance an equation. You already know how to do this. But there is a mistake people make. Br, when I come down, hey, most of the time I have to bring down those subscripts. Almost all the time. There are a few exceptions. We'll talk about that. Br2 with a 0 is going to Br with a -1. That is not going to be 1 electron. Why not? Well, because I've got this guy's not diatomic, but I have to balance him with a 2 in front of him. I'm going to need 2 Br ions to counteract, to balance for mass, the bromines on that side. That means I need 2 electrons on this side, not 1. That will make a difference. Now, the other guy who's changing is a sulfur. Sulfur is going from S with a +4 to S with a +6. How many electrons does that take? 2. This is about as easy as it gets. I don't even have to balance these to each other. I do have to label them. This guy's reduction, this guy's oxidation. All of this is points. Okay? So why do you have made a mistake already? Well, possibly with the oxidation numbers, possibly forgetting to put the 2 in front of the bromine, but that's about it. Okay, bring these numbers down. I don't even have any coefficients really to bring down except for that guy. So I've got Br2 plus SO2 yields 2 Br negatives plus SO4 -2. Got it? Now, here's where the new thing comes in. I if you haven't noticed, this isn't balanced. It's not balanced for two reasons. It's not balanced. I told you the next thing you should be looking at is charge. This guy's got a -2 there and a -2 there, which means he's got a -4 total on this side of the equation. Got it? There's nothing on this side of the equation. Okay? How do I make both sides equal? Well, water's not going to help. There's no charge on water. I'm going to have to add hydrogen ions. What side are those positively charged hydrogen ions going to go? On the right. How many will I need? 4. Got it? All right. Now, it's still not balanced. I got 4 hydrogen ions on this side. I have no hydrogens on that side. How many waters will I need to balance them out? 2. And now it's balanced. And you can do this in every reaction. Now, let me just make sure before I turn off the camera. Let me just make sure you understand a couple of things. Yes, it does happen to work out in quite a few problems, where if you put 4 H's on one side, you need 2 waters on the other. That does happen to happen, okay? But not always. Sometimes you'll only need H's, you'll only need waters, you'll need them on the same side, you'll both be on the same side. They don't always do that because of the other elements that are in here. Sometimes it works out like that, but don't just assume because I've got 4 H's over there, I'm going to need half as many waters over here because 2 times 4 is 2 times 2 is 4. Sometimes there are other oxygens and hydrogens where those guys went. All right. So my point is this: you can add H's or waters, both or neither, to one side or the other or the same side. It really depends entirely on the problem. Okay. All right. I'm going to shut this off before I do some examples.